Class, welcome to our first video of Chapter 4, Part 2. We're continuing with trig, but we're moving on to graphing now. Okay, so a couple of definitions that we need to understand before we get going. Period. We talk about the period being the time, maybe we can even say distance, it takes to complete one full cycle. Alright, so if you ever see the word period, that's what that means. And then amplitude. Alright, amplitude's a little different, or a lot different I should say. Amplitude is the distance from resting to max/min. Okay, so the distance from resting to max/min. Alright, so let's talk about this a little bit. And actually, we are going to do one quick thing here. I'm going to draw a quick little unit circle. Alright, and I'm going to put my points 1, 0, 0, 1, -1, 0, and then 0, -1. The nice thing about graphing, guys, is these are really the 4 points that are required of you. Alright, just these 4 points. They're nice and easy. They're helpful too. Okay, so what we're going to do here is we're going to say we're going to graph y equals sine x. Okay, and this is a sine function then, and it's x, and then along the y-axis is sine x. Alright, so what you need to understand here is x is just the angle, and we're inputting the angle into the sine function. So what that means here is right here where when I plug in 0, alright, when I plug in x is 0, I plug in 0 into sine, and I know that the sine is the y value at 0, which is still 0. Right? The y value when the angle is 0 is 0. So we have that. Now, what happens when I come all the way up to the top here, in between quadrants 1 and 2? Well, now I reach a maximum, right? My y value has a maximum value of 1, which means I come up to the top. And then what immediately happens? I start coming down again, right? My y drops to 0.9, 0.8, 0.7, blah, 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 until it gets to 0 again. And it keeps going negative, -0.1, 0.2, blah, 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 until -1. And then finally, it starts to increase again and again and again until it gets back to 0. And so a sine curve usually starts at what we call the resting point, or the middle of the graph, and it curves something like that. Okay? Now, cosine's a little different. Cosine's a little different. I'm still going to do this, and so now my y-axis, is cosine x. So let's think about this here. When I plug in an angle of 0, well, my cosine is already at a maximum. It's already 1. So now I'm not starting at the center. I'm starting at its max. And then what happens? As I add to my angle, as I move to the right with my angle, my cosine eventually gets to 0. And then it continues going negative, negative, negative till it gets to -1. And then it starts to come back, right? It gets less negative, less negative, less negative till it gets to 0. And lastly, positive, 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 all the way back up to +1. Alright, so a cosine looks extremely similar to sine. What's the only difference? Honestly, the only difference is where you're starting. Okay? So these are what these curves look like. And guys, this is just one period, right? This technically goes on and on and on forever and ever and ever. I can draw these things forever if I wanted to. We're not going to do that. What is important, though, is that we understand that we're going to be considering some transformations. And those transformations are an A transformation, and a B transformation. Okay, so here are two equations that we can see. What we need to understand here is that this a value, it always helps us with the amplitude. It's not quite a, it's always the absolute value of a. All right, so whatever a is, that tells you the distance that it's going to go from resting to max or min. All right, now for period, it's a little different, it's a little goofy, but what we need to understand here is that normally a period is 2 pi, right? If I have a normal, just sine of x, it goes from 0 to 2 pi to complete a full cycle. But this b value can change it. So what it is it's 2 pi over the absolute value of b. All right, so when those are fractions, we're going to have to do some work, and we'll practice that. This next part, each section, this is really good because, I don't know if you noticed, but like I kind of sectioned, right? I had my starting point, and then I had another, and another, and another, and another. So what I end up doing, guys, is once I have my period, I split it into 4. And so really, guys, all you're going to do is take your period and divide it by 4. That's going to be helpful because not every single graph is going to be nice from 0 to 2 pi. We're going to get into some really messy problems where our period could be, I don't know, like 4 pi over 3, for example, or 7 pi over 16. So I just want you guys to get in the habit of understanding these two ideas because they are going to be way easier if we can just do some quick math rather than trying to fight through it. All right, so let's jump into our first example. We're going to do 4 examples in this video. It's going to be a little bit longer of a video, I'm sorry, but I think it's really important. We're going to start with sine, and then we're going to go to its reciprocal partner, cosecant, and then we'll do cosine and its reciprocal, secant. All right, so let's take a look here. Period. Period and amplitude I always want to do first. Period, we remember, just from above, is 2 pi divided by the b value, or 2. So that's nice, pi. It's not there, but please remember to get the section, because the section is going to help us immensely when we're graphing this. Because now I just take the period and I divide it by 4. Oh, you can't see where I'm looking at. You take the period and you divide it by 4. So, pi over 4. Nice and easy. Amplitude. Amplitude, again, we look at the value out in front of sine cosine, almost like a vertical stretch. There's nothing there. So our amplitude is just 1. Now we are ready to kind of start this, guys. So what I'm going to do is draw a nice big set of axes. All right, and we remember, hopefully, our x-axis is x, and we know that our y-axis is sine x. All right. All right, well, here we go. We now know some things that are going to help us start this. We know that the period is pi, so we know that 1 full cycle is going to take pi. Even easier is that our section is pi over 4. So what I'm going to do is I'm going to break into 4 sections, and I know exactly how to label them because each one has to be pi over 4. So if this is pi over 4, then this is 2 pi over 4, or pi over 2, 3 pi over 4, and lastly, pi. Oh my gosh, what do you know? It's exactly what we thought would happen. Now here is where we have to go a little bit in a different route than what we did before, and I want to actually go backwards the same amount. Okay, things that you should keep in mind. We are always graphing 2 periods. All right, so this will always be the case. It's pretty easy to go 1 to the right and 1 to the left. Well, we have to label them. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. All right, great. The next thing that I would ask you to take into consideration is the amplitude, because we know that this is just going to go up to a maximum of 1 and down to a minimum of negative 1. Alright, and now what we're going to do is we're going to start to plot some points. Because this is a sine curve, we remember that sine, again, if you think about your unit circle, or if you think about the standard, sine is going to start at the middle because it's starting, the y is 0, and then it's going up to its max, right? From 0 up to 1. or you can see it here as well. So we have to do the same thing when we're over here. We're going to start at the middle, and then we're going to go up to its maximum, and then back to the middle, and then down to its minimum, and then back up to the middle, which would complete the full period. All right, please make nice curves. Okay, something like that. But remember, we also want to go back a period as well. In this situation, remember, I want this to look exactly the same. Or think about if you're going backwards on the unit circle now. If you were going down this way, it would go down first. So I'm going to come down to its minimum, back up to resting, up to the max, and then finally back to resting. And so I would curve something like, oh, that's not the best curve, but not bad. That'll work. Okay, so something like that. I now have 2 periods graphed. I'm ready to answer some questions. Things to keep in mind, we don't have to draw it because I just want 2 periods, but this really goes on forever, right? So if you want to put arrows, you can, because that's going to hopefully help us with domain. We should know now that the domain is all real numbers, right? There's never a gap in my graph. Well, maybe there, but I did that more just to see my value. All right, so the domains should be all real numbers. My range, what's going on here? I'm going from a minimum of -1 up to a maximum of 1. So -1 to 1. Hopefully you agree with me that these should be closed brackets. Why? Well, because they can equal -1 and 1. Now, if we look at this right now, we do not see any asymptotes, right? There's no vertical asymptotes, so I'm going to put a dash through it. And then here is the last part that we need to get in the habit of, because if you can get this now, it's going to make life simpler moving forward. Zeros. I see zeros here, here, here. Blah, they keep going. And I can even go backwards with the zeros, okay? I could make a list of zeros that goes on forever. I don't want to do that. So what we're going to do is we're going to write an equation to help us. And that equation, because our zeros are x values, we're going to say x equals. Now my suggestion is to always write your first zero first. Okay, so my first zero is right at 0. But I know that I'm going from 0 this way, how many units, and this way, how many units. And I can keep following that pattern, okay? So I'm going to say plus or minus. And if you notice here, it took me from 0 to pi over 2. So I added pi over 2. What happened to go from 0 to negative pi over 2? Well, I subtracted pi over 2. What if I went from pi over 2, another pi over 2? Oh my god, I get to pi. And I could keep going and going and going and going and going. So the rule here is that I'm going to add pi over 2, and I have to multiply it by n. Because I don't know, or I guess n just stands for the whole set of natural numbers. We'll put it like that, right? It goes on and on and on and on forever. Okay? Okay, let's move on to number 2. Remember what we said, we're going to now graph a cosecant, and that should go very nicely with sine. So let's take a look at this. When we see cosecant or secant, I want you to first think about its reciprocal function, or its reciprocal partner. Okay, so right below it, this is what I'm going to have to kind of think about first. Now period should be the same, so period is going to be 2 pi divided by b, which is 3. That's good, it's reduced, we're fine. Section is going to be a little tougher. Let's think about the section here. So section is going to be 2 pi over 3. But then I need to divide it by 4. So instead of dividing by 4, I'm going to multiply by its reciprocal, by 1/4. And let's see here. So 2 pi over 12. Oh, that's just pi over 6. All right, pi over 6 is my section then. Amplitude, hopefully you agree with me, is just my a value, or 4. All right, if you want to be super exact, you can put absolute value of a is equal to 4. All right, so here we go. Now we have enough to start to graph my sine function. Oh, not the straightest line. It'll do. Okay, so we have our axes. All right, we know our section is pi over 6, so I'm going to make 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to label. So this is pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. And then I already have these then. So negative pi over 6, negative pi over 3, negative pi over 2, negative 2 pi over 3. All right. Let's see now. So what we're going to do, we are going to kind of, oh, actually I forgot my amplitude. Okay, so we need amplitude for negative 4. Okay, so what we're going to do here, guys, is we are going to dash or dot the sine, right? We're not graphing the sine function. It's just a helper for us. So what I'm going to do, I'm going to use the same strategies that I used before. I know it's a sine, so I'm going to start at the middle. I'm going to its max, to resting, to its min, back to resting, and I'm just going to kind of dot this one so I understand the general shape. Oh, not the best, but it'll work. And then I'm going to do the same thing on the other side. And I'm going to dot, 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 dot. Okay. We now know what the y equals 4 sine of 3x graph would look like, but I don't want sine. I want cosecant. So the next thing that we have to understand, guys, is that cosecant, we'll just say this, cosecant is the same as 1 over sine. So we basically have to take the reciprocal of what we see here. Well, that should hopefully throw some red flags up. That should throw some red flags up because I know that there are places where my x value, or my sine, I should say, is 0. Yeah, not x. My y value is 0, excuse me. And I can't do 1 over 0, right? When we take 1 over 0, we get undefined. And when we have undefined values, that leads to, you guessed it, vertical asymptotes. Okay, so anytime you see a 0, you need to place a vertical asymptote. That's the first step. All right, and we will write about those in a little bit. The next thing we need to think about here is the fact that, let's take this point for example, okay? Pi over 6, or up at 4, okay? Well, we know this is a maximum. If we were on a unit circle, this would be at 0, 1. All right? Well, we know that when we take the sine, it's 1, but also when we take the cosecant, it's going to be 1, because the reciprocal of 1 is just 1. What's going to end up happening, guys, if you think about it, on my sine curve, right, as I move a little to the left or to the right, that number gets a little less than 1. And when I do 1 divided by that, that actually makes it go up. So it's really nice. What's going to end up happening here is you're just going to end up drawing these like mini parabolas in the sections based on where the sine curve is. So now that I'm down here at -1, and like again, let's say I went to -0.5. Well, what's 1 divided by -0.5? -2. All right, so it should make sense that we're getting more and more negative on this part and more positive up here. And then we do the same thing on this side. And lastly over here. And now we have our cosecant curve. I'm going to put that in green so you understand that that is what I'm looking for. All right. Now we're ready for some domain work. All right. Well, let's think about this. All right. Domain, we're going to say and start with all real numbers, because there's a lot of places, right? But there are very specific places where it is not ever going to hit, and those are the asymptotes. So we know that there are going to be restrictions. X cannot equal, and then guys, it turns into the same thing that we did with zeros on the other page, right? I find my first asymptote, which is at 0, and I know what's happening. Well, there's another one at pi over 3, or 2 pi over 3, or negative pi over 3, negative 2 pi over 3. So what is the gap between the asymptotes? Well, from 0 to pi over 3 is just pi over 3. So my gap, or my rule, is pi over 3n. All right? Range is a little different than sine. We have to remember sine, we want everything between the min and max. But now for cosecant, we want everything outside the min and max. Well, I guess it's not the min and max anymore. Hopefully you understand what I'm saying, though. All right? So we know we have this point at -4, and we know we go down forever until we get to -4, and then we make a huge jump to +4, and then it goes up forever. So I know that I'm going to be from -infinity to -4. I bracket it because it does equal -4 at a point. And then I union it with 4 to infinity. All right? Asymptotes? Asymptotes we actually already did, guys. So if you did your work for domain, you don't have to redo it. X cannot equal 0 plus or minus pi over 3 n. Beautiful. And for zeros, for right now, because there's no shifts up or down, hopefully we notice on our green graph, there are absolutely no zeros, okay? Now, in future, we might shift this up, and we might have to figure that out, but for right now, none. All right? Okay, let's move on to our next one. We have a cosine graph. Cosine graph is going to act very similarly to sine, but just some slight differences, all right? So when we start this, we get our period, 2 pi over b is pi. Well, we need our section, so our section is pi over 4. Amplitude, nice and easy, 5. This isn't that bad. Let's sketch a set of axes. I'm going to make this a little taller. All right. And now I section. And again, remember, the sections that we're using directly relate to the unit circle. That's why we're splitting it into 4. Right? Our first section goes from 0 to 90, or 0 to pi over 2. And then the next section, pi over 2 to pi to 3 pi over 2, 3 pi over 2 to 2 pi. All right, it's the 4 quadrants. That's why we're sectioning this off. So we need nice sections, something like that, and then go back in the other direction, 1, 2, 3, 4, and then label them nicely, okay? So pi over 4, pi over 2, 3 pi over 4, and pi. Just check. We're good. That's what we wanted. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. All right, amplitude time, 5, negative 5. Okay, I think we are good to go. All right, things we need to keep in mind here as we switch from sine to cosine. You can think about it a couple of ways. If you think about it from our original pictures, what did we notice about cosine graphs and sine graphs? Okay, sine always starts at resting. Cosine always starts at the max. All right, so that's one way to think about it. The other way, if you want to think about it, is just remember that at our starting point, cosine is the x value, and the x value is always going to be 1. All right, so that's why it's going from 1 down towards 0. Right, it's starting at its max. So now I know that here I'm going to be up at the max, to resting, to min, to resting, to maximum, and then same thing going back the other way. Resting, min, resting, max. And then we just get to draw the curve, the most fun part, right? Please do a really nice job with your graphs, or the nicest job possible. I'm not looking for masterpieces, but I want, like, decent graphs. All right, remember, if you want, you can do that. I need to be able to see that they're curves, all right? I don't want to see no mountains, okay? None. All right, this one was nice and easy, right? We're ready for domain here. If we take a look at domain, there's never any gaps in our graph, okay? So we have all real numbers for domain. And then we're back to the range being just very much between our min and max, okay? So this is nice and easy, -5 to 5. Again, there are no asymptotes. There should never be asymptotes, for sine, cosine. And then zeros. We need to know x equals, and we need to know basically what the first zero is, and then the space between the zeros. Okay, so my first zero that I graphed here was pi over 4. So I start at pi over 4. I know I'm going to add or subtract the distance between the zeros. So now from pi over 4 to 3 pi over 4, maybe you can do that one in your head, right? Take away pi from 3 pi, that's 2 pi over 4, or pi over 2. That's great. If you want to do that in your head and understand that that's just pi over 2, then I'm good with it. One suggestion that I will make is if you can figure out its two sections, and it always will be, you can always help yourself out by moving your two sections over and just doing it that way, right? So instead of thinking about doing subtraction, if I just take two sections, slide it over from 0 to, pi over 2. Pi over 2. Okay? All right, almost there, almost done. We'll save the best for last. A nice, crazy secant graph. Okay, so remember, when we're graphing secant, we first need to graph cosine. All right, we need to get the cosine graph first. Period. 2 pi over b. Oh boy, 2 pi over 3 halves. I don't want to divide by a fraction. I want to multiply by the reciprocal. So 2 pi times 2/3. Well, we can do that. Put that over 1. All right, we got 4 pi over 3 is our period. Right? Are we good with that? I kept, I changed, I flipped. Keep, change, flip. I multiplied by the reciprocal instead of trying to divide by a fraction. All right. Now we still need the section, which could also get messy. I think, again, I'm going to take my original, and instead of dividing by 4, I'm going to multiply by 1/4, which is actually really nice, because what happens with these 4s? Cancel, cancel, and we know our section is pi over 3. Amplitude. Amplitude is the absolute value. So our amplitude is 1/4. We will talk about, in a very quick second here, what's going on with this negative. All right, we will get there in 1 sec. All right, I think we have everything that we're ready to start plotting this. All right. All right, we can definitely section this off now. 1, 2, 3, 4. 1, 2, 3, 4. And we know that our sections are in pi over 3. So pi over 3. 2 pi over 3. 3. Pi. 4 pi over 3. Negative pi over 3. Negative 2 pi over 3. Negative 3 pi over 3. Negative 4 pi over 3. All right. When we graph our amplitude or plot the points that we need for amplitude, again, it doesn't have to be perfect, but we want 1/4 and negative 1/4. And now we're ready to kind of dash our cosine graph. Remember, we dash or we dot it. We do not want to graph it actually, because that's not what we're looking for. We're looking for the secant graph. Now, one thing we need to think about here is what a negative out in front does. A negative out in front, if you remember, a negative outside of a function should be a flip over the x-axis. And it works the same way, guys. Transformations are really basically working the exact same way as they did before. So a point that would have started up because it was cosine, and cosine usually starts at its maximum, because it's negative, is actually going to start at its minimum and do the exact opposite, right? So if it were positive, it would have started max, rest, min, rest, max. Now it's min, rest, max, rest, min. And then the same thing on the other side. Okay, so we dot our cosine graph. Again, we dot it because that's not really what we're looking for. That's not really what we're looking for. We're looking for secant. So we also need to remember that secant is 1 over cosine, which we already knew, but what's important to understand is that we can't have zeros, right? Can't have zeros. So whenever the cosine is equal to 0, or whenever y is equal to 0, there needs to be, you guessed it, vertical asymptotes. What I will let you guys know, and hopefully you'll just kind of pick up, is that the rest of it is the exact same as cosecant. Alright? It works the exact same way. The idea of taking, maybe let's start at this point, alright, down at the bottom here, and then taking the reciprocal of every value here, well, all that does is it makes kind of this goofy looking parabola between the asymptotes. And another one here, between the asymptotes. Oh, that's not the best one, but it'll work. And another one, between the asymptotes. Alright, now on both ends, if you notice, like this is one full cycle, right? I went up, down, and then back to up. Right now I really only have 1.5 periods graphed. I need to remember these over here. Okay, and this one over here. Oh gosh, that was terrible. I ended like that. That's bad. Alright, but again, think about this, right? If I start here, when I'm done with 2 periods, I should end at the same place, right? If I had continued this, it would have started to look like this again. Alright? So, almost done. Let's finish up with domain, range, asymptotes, and then we will call it domain. We're all real numbers, however, what? There are specific places that x cannot be, and we know they are the vertical asymptotes. The vertical asymptotes, if we notice, the first one I think I sketched maybe was pi over 3. We'll start there. And then what are we doing here? What's our rule? How are we getting from pi over 3 to pi? Well, you can either do that subtraction and say it's 2 pi over 3, which it is, or remember it's 2 sections, and it will always be 2 sections. So you can use your fingers to help you figure out what 2 sections is as well. 2 pi over 3. 2 pi over 3, and then remember that's the rule, so times n. Range, once again, it's actually everything but the middle here. So I'm going from negative infinity all the way up to negative 1/4, bracket, but then I go back down, and then what happens? I pick up at positive infinity and come down to 1/4, and then back up. So 1/4 to infinity. Asymptotes we already did. Our rule was the first one plus the pattern or the rule. We got it. Last thing, zeros. For secant and cosecant, you can't have any unless there is a vertical transformation or a vertical shift, okay? Right now, if you look, it's never crossing. The green is never crossing the x-axis. So we put it on. Alright? Okay, so this is a good introduction. I know it was a little longer, but I think this is a nice walkthrough of how to graph our 4 trig functions. We'll practice more in class. Have a good day.